right, good morning. Thank you for staying on and joining us this morning. I'm Amanda with stemCONNECT, and we're at USF, and I'm going to let Jordan talk to you a little bit about what we're doing here.
All right, nice. So everyone, as Amanda said, my name is Jordan. I am one of the exhibitor directors here at USF Engineering Expo. And yes, we are widespread. We're over 65 acres. Welcome to the 2020 USF Engineering Expo. We have been here for over 49 years. This is actually our 49th year. So for the past 48 years, we've been really gathering different student organizations and different corporate personnel as well to show really K through 12 students and really anyone throughout the Tampa community what the STEM field is like. Science, technology, engineering, math, really creative minds just building and developing new different things. It's really energetic and exciting to be here. This is actually my third year on the Engineering Expo board. So, I love it here. I always love seeing all the schools, all the teachers, walking around, just enjoying everything, getting to play in, all the play, the science experiments, the Play-Doh. It's a really great experience, and I'm really honored to be here and to be able to, show you all what we're all about. From before, we were, a little 30 acres. We probably started about 15, grew to 30, grew to 50, and now we're spread over 65 acres.
That's crazy.
So it's really big. We all have to make sure we have on our walking shoes, which I think we definitely do. There are exhibits everywhere, from cars that people built out of electric cars to lasers that do work on cancer treatments, to just a whole wide breadth of experience that we have here. So,
This is going on for 2 days.
yes,
So
we're
they
here
can come check
today.
it out live tomorrow if they want.
Yes, definitely. We're here today from 9 to 4. We're here tomorrow from 9 to 2. We've been setting up, we've been planning it since, last year, around September, but we've been setting up ever since Monday. Last night we stayed till about midnight. So there is a really lot that really goes on to planning this. We do have over 65 exhibitors this year. So that's really, really big. And, as we're walking around and as you're looking at, the different things we have, you'll kind of see, why people are really excited to want to join and exhibit at Engineering Expo. It's like a really great opportunity. And again, thank you all for being here. I'm so excited to get started.
So thank you all for joining. We're going to give you just a snippet of those 65 or plus exhibitors today. We're just going to show you a couple of them. We only got 2 hours, but we're going to make it a fun-filled 2 hours. Please don't be shy with those questions. We are here to make sure that they get answered for you, and to be live the entire time. So definitely send those questions in as they come up. If we do lose connection at any point, we do have a backup set in place to keep you online, and we will join as fast as possible. But we are outside dealing with the elements today. It's a little cold, a little rainy. So please bear with us, but we promise to show you as much as we can. And Jordan's going to be one of our amazing hosts today, and he's going to be the one starting us off. So where are we headed first?
First, we're heading to the Engineering Medical Society, yonder. All right, everyone. So, and let's introduce you to my good friends, Brian and Vincent.
Morning, Jordan. How are you?
All right, I'm good. How are you all?
Doing great. Brisk morning, but it's going well.
Yeah, I bet. All right, so just tell us a little bit about your organization, why you're here, and what makes you excited to be here at Engineering Expo this year.
Okay, so this exhibit is the Engineering Medical Society, and what we'd like to focus on is the applications of engineering into the medical field and the effects of engineering has in the body. So biomedical applications,
Right.
the different technologies used for surgery, everything in healthcare. And then, so what we like to do is we have a bunch of different guest speakers. We have physicians, medical school students, PhDs. We have guest lecturers. Like today, for example, we have Dr. Story Musgrave, neurosurgeon, trauma surgeon, and 6-time space shuttle astronaut. So We're going for about 4 years now. This is our 4th year doing Engineering Expo. So let's go show you our laser.
Nice. All right. Your first sneak peek at an experiment. Let's see what happens. All right.
So here we have our thermal laser experiment. This is an application of the laser institutional cancer treatment. So normally with this treatment, it's used to to kill cancer cells in hard to reach areas such as brain tumors. So this time our brain tumors will be balloons covered with chalk powder. So you ready?
All right.
The wind died down a little bit.
It is very windy today.
It is a very windy day. Yes.
Very windy today.
Let's go help it out.
All right. Nice. All right.
Check us out. And remember, go Bulls.
Go Bulls. Yes, definitely go Bulls.
And we still have an event tonight. Dr. Story Musgrave from 5 to 8. So.
Nice. Thank you, Brianna. Thank you, Vincent. And I hope you all enjoy the. Thank you. I hope you all really enjoyed that because I was blown away. All right. That was your first exhibit. And now we're going to head on to our next exhibit, which is MOSI, the Museum of Science and Industry. All right. And now we're on to our second exhibit, MOSI. So how are we all doing here today?
Good. So I'm Ramila. I'm from MOSI. MOSI is the Museum of Science and Industry, and we brought some fun science things with us today. We have our Van de Graaff generator over there. We talk about electricity. We also have our energy stick, which tells us if things are conductors or insulators. You want to try this out with me?
Yeah, definitely.
So if you hold one end, and then put my hand on the other one, we're completing a circuit with our body and the electricity going through us. And you can kind of tell something's a conductor or not. We'll try this. So now the electricity is going to do this thing. And like try this. That doesn't work because it's made out of rubber. So it's kind of easy for us to tell whether something is a conductor or not. Fun way to do that.
We're completely delayed, but it's okay.
Okay. Sorry. All right, and then the next thing that I can do is we're going to do some liquid nitrogen activities.
Switcher thing.
So I'm going to pour out the nitrogen. I don't know how much you can see it.
I guess I should say. So smart.
I can show it to you a little bit closer. We use this to do a bunch of different experiments where we show what solid, liquid, gas works really well for elementary school students to see some things changing states of matter really, really quickly. I'll leave that right there. And I have a balloon that we blew up before you guys got here. I'm going to put that in our little box. There. Right, and
And then I have a few more balloons. Have some volunteers to maybe blow up a balloon. Oh, I didn't see that. While you guys are blowing them up, I can put a second one in here.
I'm so scared I can get rid of them. But I'm not convinced.
That's a very common reaction. So a lot of, when we do this, a lot of people think that, oh, they're popping in there. I get some kids and some adults saying they're melting in there. Some people think you carved a hole in the table. Didn't. Your table is fine.
So what's actually happening?
So we'll see when we get them out. I'm gonna put a whole bunch in there. But since our liquid nitrogen is about halfway filling this box, it's 325 degrees below zero inside the box. So if you've ever done an experiment where you blow up a balloon and you put it inside your refrigerator or freezer, you'll notice that when air gets cold, it shrinks or contracts. So it's kind of happening on a much more extreme scale in there. Last one. I forgot how many I put in there. But I'm gonna bring them all out and put them on this table right in front of us. And you'll be able to see what's inside.
Does it evaporate?
The liquid nitrogen is boiling. Yeah. So the nitrogen is boiling at room temperature right now. So if I take this one out, you look at the very bottom, you see the liquid sloshing around. I'll take another one out so you might be able to see it a little better. So what actually happens is that the air that's in the balloon condenses, so it turns into liquid air because it's cold enough in there to do that. There's another one, you might be able to see it better. Like a dark shadow down there.
And when it comes out, does it reinflate?
So when it comes out, the liquid air gets exposed to the warmth in the room, and it'll fill back up to pretty much the exact size that it was before. So the air that's inside the balloon never really goes anywhere. It just changes states of matter from being a gas, then a liquid, and then back to a gas. So actually when the gas turns into a liquid, it takes up about 700 times less space. So when we put all those balloons in there, we could fit a whole bunch of balloons all in this box. Because as a liquid, the nitrogen will take, or the air will take up 700 times less space than as a gas.
Awesome. So as a reminder, if you have any questions, don't be afraid to send those in. That was really cool.
Do you guys have any questions? Yeah?
How does the balloon actually fill so quickly?
How does it fill up so quickly? So even though it feels a little chilly out today, it's pretty warm in here because our liquid nitrogen's boiling temperature is 325 degrees below zero. So it's almost like, you know, when you boil some water for tea or pasta, it takes a few minutes, right? But here, you're doing it very quickly because the temperature is so much higher than the boiling point. So it's probably what, like 70 degrees in here maybe, and this nitrogen boils at 325 degrees below zero.
All right, everyone. I hope you enjoyed that demonstration. Thank you, Mosey. Thank you.
So we're Engineers Without Borders. We're a group of engineers, and basically our goal is to help out the community and the environment any way we can. We have two global projects going on, one in the Dominican Republic and one in Bolivia. In the Dominican Republic, we're installing water catchment systems for people's homes because they have to walk 2 miles to the nearest water source, and it's really dangerous because they have to walk through steep, rocky hills. And in the we're gonna install latrines because they don't have access to toilets, and they openly defecate outside in the grass, which harms their crops and infects it affects their water also. So we're trying to find a way to design latrines and make it more clean for them. We're also volunteering locally in Tampa, doing oyster bed restorations and coastal cleanups and whatnot. And we've grown tremendously the past year or so. We've, we're an awesome organization, and we hope to continue growing and recruit new people.
All right, now get a load of this. Just get a whiff of this. Engineering at its finest. Students year round, they take all the parts they can find and build little carts like these from scratch. And there are a whole bunch of races that go on throughout the Tampa Bay area and really throughout the country, to be honest. And they go take these to all these different events, race them. We here at USF actually have a cart ourselves, and we've taken it to many competitions and races, and we've won a lot of awards for it. This looks like maybe one of the high school teams, to be honest. We do have high schoolers that build carts like these, different other um, entities that build carts like these as well. Tomorrow there's actually going to be a big race in the lots, in one of the parking lots. They're going to close off the whole parking lot, and all the people with these carts are actually going to race them. It's actually really nice and really intense. Typically they can go up to speeds of about 40, 45 miles per hour. And once you get the hang of it, you can just start, you can just put your foot on the gas and just start whipping around all the corners without even fear.
So in mechanical engineering, we have a lot of courses where we are encouraged to get into competitions. And especially, I can recall like last semester during my kinematics and dynamics class, we were encouraged to produce a whole mechanical moving analysis of our own, using what we learned in our classes. And the thing that I decided to make was a catapult. Basically, my goal was to create an automatic ping pong ball thrower so you could play with yourself.
How
And
fun.
yeah, it was a lot of fun
Yeah.
doing that project, and it taught me a lot. And that's what I really love about being in the STEM field and being at USF. We're really, really encouraged um, to be hands-on and really get a real feel of the real world, and instead of just learning the theories, to actually know what the practicalities are of being in the field and being in STEM. I'm Rifa Ahmed, by the way, and I'm a mechanical engineering student at USF. And I'm also the director of exhibitors at Engineering Expo this year. I was also involved last year as a volunteer. I also demonstrated a project here, which really inspired me to find a position in the board, because I felt like being a part of an event like this would really give me good experience, and especially in terms of people skills and learning to interact with kids and inspiring them. So I felt really motivated to be more involved with the expo.
Yeah, so we love that you're here today helping us with all of this. So it's absolutely amazing.
Yeah, I'm glad that you came here to our school, and that you're recording all this for everyone to see.
Yes, awesome.
Thank you for that.
Of course. Is Jordan getting an interview with the students right now? Thank you.
Yeah. I think we can go over there and see what they're up to.
Good afternoon or good morning, maybe. I don't know what time you guys are watching this at. My name is Shanika Singh. I'm the Vice President of the Society of Automotive Engineers. So as you guys have seen, that was our previous season's Formula Style race car running. The students here are the engineers here. We design, build, and compete. So everything that you guys saw on the car was something that we've either designed ourselves, we've sent it out, we bought it. The steel frame chassis, for example, we sent it to a sponsor all the way up in Canada, They chop up some tubes. They send those tubes back. We'll come and we'll weld the frame and the chassis together by ourselves. So when you work with a team like us, you get a lot of like practical manufacturing and machining skills. We do a lot of let's say machining with let's say CNC equipment that we have access to, and that's given to us through the DFX lab and a lot of other things. We do a lot of testing with professional equipment, right? And actually, we're doing some of that today as well. So definitely something to check out if you guys ever get the chance, or if you come to university here. So this is actually maybe not the best day because of the weather, but I think we're looking to tire data and stuff like that. But it's heavily affected by temperature, unfortunately, right? So we usually like to get out on a hot day because that's usually how we run, right? We also go to competitions, right? And speaking of hot asphalt, we'll be going to California in the summer, as well as Barrie, Toronto, or Barrie, Canada, right? Yes, it's super fun. It's really fast. I can't drive the car and read the dashboard at the same time. Everything happens in a flash, right? So I'm not one of the drivers, but Nathan, our lead engineer, it's crazy to see like how quickly he's able to do things, maneuver, read, adjust dials and knobs and stuff like that. It's truly a skill. So we start design, we'll say after competition. So this might be in June or July. It'll run all the way into, I'll say, November to December. So then that's when we send all of our orders out. And then we have December. That's kind of almost like a break month. We do work, but not that much. We're waiting on stuff. The chassis comes in at the beginning of January. Then we get to work, right? So right now, if you were to go to our shop, you would see our new chassis fully welded up, right? And then after that, it's as the orders come in and we start making our parts, we drop them in, and hopefully by April, we'll have a new car ready to go, and we'll start testing, and then in June we go to comp. So we are a student organization, right? But a lot of the things that we learn in class, this is direct application, right? So it's not everything that we do is practical, and that's kind of my favorite part. I feel like this prepares me for the engineering world. Absolutely nothing. Just a willingness to learn is really what it takes. We teach everyone whatever they need to know, right? Maybe if they want to do a little head start, they can look at the different parts of a car and get familiar with that, because the difference between this and a sedan isn't that much. We don't have AC or rear view mirrors, but other than that, for the core parts, they're about the same. So our transmission, the engine that we pull is from Honda CBR 600, or that's the engine that we use. The transmission is built into the engine, so that's all one singular piece, right? And the shifting mechanism is pneumatic and is a sequential transmission, so it's manual-ish. It's kind of how we'd put it. We have to change the gears by clicking a shifter button, and it goes either up and down. A traditional manual gearbox, you kind of get to choose which gear you want to go to at any time.
For green and gold, we stand united. Our beacons lighted and noble to see. USF Bulls are we. For USF will always be. With all our might, we fight the battle here and now, and we will win the victory. SOUTHFLORIDA. South Florida. South Florida. Go Bulls! Woo! Yeah. I actually remembered. I'm so surprised. All right. How are we doing today?
Good.
All right. We're here with Junior Chefs of America, and actually, I'm going to hand it off to Rifa to take on this one. All right. It's my birthday.
Hi, how are you? How are you feeling about the expo today?
Good. We haven't started yet, but we're gonna make like a homemade whipping butter, which should be really fun. We're gonna put some like heavy cream in a box and then kind of shake it until it like forms. So that'll be fun. That's always like kind of a cool experiment to do.
Wow, that sounds really interesting.
Yeah, all the kids are gonna be really excited about it. We have a little spinning wheel too that has pre-prizes. We have like candy and this little cake Southern Living cooking book. So
Oh,
people are pretty excited about that.
yeah, that sounds amazing. So, would you like to demonstrate your project and show it to us?
We're actually waiting on the whipping cream, to be honest.
Oh, okay.
The one store we went was a little low on it apparently, so she had to go to a couple different ones to find it. But
Alright.
I can show you kind of what we're junior chefs of America.
Yeah.
And just kind of talk to you about.
Yes.
So we're actually cooking school. So we have kids classes. The first kids class is always free, and we have a bunch of different programs. Like we have a 10-week certification program that actually my colleague's going to be teaching soon. So that would be pretty fun. Yeah, so we actually all of our classes have some educational aspect to them. So a lot of times we have like math, science, reading, writing, like all that kind of thing. So they're learning how to cook, but they're also getting an educational process, which is pretty cool. We also have, we're associated with Igor a little bit, so we have a Cuban sandwich festival that's coming up where the kids are going to make Cuban sandwiches and they're going to have a contest. Whoever wins gets a prize and gets to do all that kind of stuff. We have a bunch of different fun like field trips, summer camps, and all that kind of stuff. We also have adult classes, so
Hey guys, so now we're going to be talking to American Structure Point. Um, let's go see what they're up to. Hello, how are you doing today?
How are you?
I'm good. How do you feel about the expo?
Oh, I love it. I love it. I was
Oh,
part of it as a student,
yeah.
and I just now I get to exhibit, and it's a cool experience. It's cool to be able to talk to these K through 12 students and really get them engaged in the engineering and STEM fields.
Oh, that's great to hear. So could you tell us a little bit about your demonstration here?
Yes, this is a roundabout intersection. We specialize in constructing these intersections instead of traffic light intersection per se, where these roundabouts are a lot safer and they help the traffic flow a lot better. So where at a traffic light you might have like a lot of these head-on collisions or these like T-bone side swipe collisions. Really the worst that happens here is where two cars are coming and they just kind of bounce off each other a little bit. Just a little bit of bumper damage, not too bad. So it's a lot safer, and we found that it reduces severe crashes by about 80 to 90%, which is significant.
Wow.
So our Tampa office is fairly new. We're about a year old, but we're looking to grow and build more of these roundabouts throughout the state of Florida.
Yeah, yeah, that's true though. I believe that building more of these would actually potentially reduce the number of accidents in Tampa because I've been seeing a lot of car accidents recently. Yeah.
There's a lot of intersections and roads in Florida that could benefit from roundabouts.
Yeah, yeah, I agree. All right.
Absolutely.
Thank you so much for speaking to us about this, and we're really glad that you're part of the expo this year.
Absolutely. We
All
hope
right.
that American Structure Point will be here for years to come.
Okay. All right. Thank you.
After we're doing it for stemCONNECT, so what we do is we reach the students that weren't able to come.
Okay.
So you're actually streaming live to a couple different classrooms
Oh,
that are
that's
learning about just different engineering paths and different things that they can do.
Oh, I love
So
it.
we actually might lift you guys up and send you information to do maybe more one-on-one classes. in
Oh,
the
absolutely.
future.
Yeah. Absolutely.
Thank you so
Love
much.
All right. Thank you.
You guys have a good one.
You too. All right, so I'll be passing the mic off to Jordan now, and I have a class at 11, so I'll be leaving. So, bye bye. Take care.
All right. Yes. Thank you, Rifa. Let's head off to our next exhibit.
So, hello guys, my name is Min Coco. I'm an assistant corporate director for USF Engineering Expo for this year, 2020. And now you guys are at the Chemistry Society where they're going to be talking about some interesting experiments they're going to be conducting. You're kind of talking to some people right now, so we'll just wait for a while. When they're ready, I'll just pass on the mic to the president.
Want to tell us how we get involved with
So the question is, how do you get involved with the Chemistry Society?
We have the Chemistry Society tutoring lab. It's in NES 115. Over there, we appoint volunteers for tutoring. So they can submit applications to us through an online forum. We review the applications and then have the tutoring lab up. We tutor for chemistry, orgo, calculus, most STEM subjects, and we also offer them volunteer hours. So they sign in and sign out in the lab. So based on that, we sign off their volunteer hours. A lot of medical schools or other organizations that require volunteer hours for certain applications. So that's one way you could get involved. We have events every month. We have like a system. We have one event every month for sure. That's like the minimum. We have more than that. Like today we have the expo, and then on 25th of this February we have a program in a box event where we're gonna have guest speakers come in and lecture about chemistry and food. So we have events like that. Attending events like that is great. So that's one way to get involved with us. Again, we are always out at the expo, so that's another way to get involved with us. We have things like brewery tours planned out over the semester, and yeah.
Awesome. So what are you guys doing here today?
So here we have this thing called a hand boiler, and when you put, so this is ethyl alcohol, which is ethanol. When you wrap your hands around it, it's supposed to start boiling, but my hand doesn't have enough heat right now because it's too cold.
Too cold right
Right, yeah.
That's awesome.
So what happens is ethanol vaporizes because of the heat of your hand, because the heat of your hand is enough for it to vaporize. And then after it vaporizes, the vapor inside it expands as you provide more heat. And then when it expands, the vapor bubbles up because it's a gas. It bubbles up and then it produces a boiling effect. So it's not actually boiling because that's not enough heat, but it's called a hand boiler because like that's the concept behind it.
What about this right over here? Can you talk to us a little bit about that?
Yes, over here we have this is iron, or we can call it magnetic sand, but it basically has iron inside it, which has magnetic properties. And then this is the magnet. So when you flip it over, it produces a pretty cool effect, like yeah.
That's awesome.
So as you can see, it's only in the bottom of that thing because the magnet is only at the bottom. So that's like a demonstration of magnetic properties of iron or magnetic sand.
Perfect.
So the science behind this is that when you light a candle and if you keep it for a while and then you blow it out, what happens is the the candle wax actually vaporizes as the candle burns. So whenever you blow out a candle, if you look closely, there's always vapor coming off of it, and that's actually vaporized candle wax. So if you hold a lighter or like a flame near the candle wax that's vaporized in the air, you don't even have to get it near the wick. It's going to light up the candle without even getting it near the wick.
A little lab right here. This is the Institute for Electrical and Electronics Engineers. They participate in a lot of conferences. They do a lot of soldering. They do a lot of workshops, Python. So if you're ever interested in programming and learning different programming languages, if you're ever interested in learning different design software like Arduino, PCBs, soldering, if you're ever interested in, building a robot for a Southeastern Conference, this is where you can learn all about it. All right, now we're gonna go. Now this is where we really get our steps in because we are going on a journey to another special place in Expo. And this special place has Lockheed Martin.
Hi, my name is Heather Kurtz. I've been with Lockheed Martin for 11 years, and I've done various things here at Lockheed. I've been a software engineer, systems engineer. I did flight test for full flight simulation with the pilots, and right now I work on a part of digital transformation, which is transforming Lockheed Martin into the next generation of technology. And so today here at USF, we brought a couple of our flight simulators. Lockheed Martin owns a company called Prepared. It's a full flight simulation project based off of Microsoft Flight Sim. So you can go on and purchase Prepared and actually do flight simulation at home. And so we wanted to show the kids here that it's really easy to set up that in their own house. You can just go on Amazon or wherever and purchase the stick and throttle, and running the Microsoft Flight Sim Prepared in the background, you can run flight simulation testing the way that pilots actually do. So we have 4 laptops set up in here, and the kids are actually, they go in and then they fly it, and they're actually really good at it. So, and then that's how we train pilots as well. So that's a drone, and it's an example of what a drone would look like. Lockheed Martin is just getting into the drone industry, and so we just wanted to give an example of some of the things that we're bringing forward into this new drone era. So Lockheed Martin employs 100,000 people, various, not just engineers. We have various people throughout all kinds of industries. If you're looking to get into some type of a flight simulation or flight, that type of realm, Emory, Embry-Riddle, yeah, is right up the street in Daytona. That's a really good school for aeronautics. Lockheed Martin recruits from all over the world. We have facilities all within the states, all over the country, UK, everywhere. And so I've actually had the opportunity to travel with Lockheed. I've been to Australia. I lived in the Netherlands for 2 years. And so that's the versatility of having this type of a virtual environment, is you have the flexibility to move around and to work virtually. And so if you're looking to get into this type of industry, heavy on math, a lot of math. It kind of just depends on what realm you're getting into. So Lockheed has, of course, aeronautics. We also have Navy ships. We do a lot of recruiting from within the military. So if that's an area you want to pursue for school, we feed into the military as well. UCF has a feed-in program to Lockheed that is specific to the engineering program, to the manufacturing engineering as well. Yep.
Thank you so much for sharing.
Yeah, sure. Yeah.
We're just gonna keep bopping around and showing some of the kids. We might try to peek in on one of
Yeah, sure. So there's the simulators. We also brought the Spheros, which is not owned by Lockheed, but we wanted to show the kids that they can learn programming through visualization. So it's an app that you can get on your iPad, and you can purchase the Spheros. It's a robot, and you can either program it yourself, kind of like you drag and drop blocks into the programming, or you can program it in JavaScript, and you can make it do sounds, you can make it move in any direction. So that's kind of, the type of thinking that you need to get into when you want to go into that type of an engineering degree.
Awesome.
Yeah.
Thank you so much for
Yeah, thank you. It was nice meeting you.